In this lesson, we're going to have a look at Unit 4, Chapter 4, Trigonometry in a Unit Circle. We're going to continue with Trigonometric Ratios, Part 4. I want to look specifically at finding special angles given their trigonometric ratios. As I said, the focus for this lesson will be on identifying the measures of angles that generate specific trigonometric values. A couple of things we need to refresh our memory on first, the cast rule. Notice the word cast can be spelled starting at quadrant 4, going in this direction. C-A-S-T spells the word cast. And of course, it represents where things are positive. So cosine is positive in quadrant 4. They're all positive in quadrant 1. And when I say all, I mean sine, tan, and cosine. Sine is positive in quadrant 2, and tan is positive in quadrant 3. Of course, if we know where things are positive, we also know where things are negative. For example, if I know cosine is positive in both of these quadrants, then I also know that cosine is negative in these two quadrants, quadrants 2 and 3. If I know that sine is positive in quadrants 1 and 2, then I know that sine is negative in quadrants 3 and 4. Same is true with tan. Tan is positive in quadrants 1 and 3, so tan must be negative in quadrants 2 and 4. And of course, wherever sine is positive, the reciprocal ratio cosecant is also positive. Same is true for cosine. Wherever cosine is positive, then the reciprocal ratio secant is also positive. And of course, the same is true with tan. Where tan is positive, cotan is also positive. So the cast rule really helps us identify the quadrants where each of these trigonometric ratios are both positive and negative. Another thing that's critically important that you need to remember is the reference angle and the point associated with each reference angle. So if you have a reference angle of 30 degrees or pi over 6, then we know the point associated with that is root 3 over 2 and 1/2. A reference angle of 45 degrees or pi over 4, the reference angle is root 2 over 2 and root 2 over 2. And finally, a reference angle of 60 degrees or pi over 3 has a reference angle of 1/2 root 3 over 2. Note again that the 30 degree angle and the 60 degree angle, the coordinates are switched for each of those. Let's have a look at an example that involves the cast rule, in which quadrant is tan positive and cosine negative. It actually says where's tan theta greater than 0 and cosine theta less than 0. Of course, that means the same thing. Whereas tan greater than 0 means where is it positive, whereas cosine less than 0 means where is it negative. So all we need to do is consider again our cast rule. Where is tan greater than 0? Tan is greater than 0 in two quadrants. It's positive in both of these quadrants, quadrants 1 and quadrant 3. And cosine is less than 0. In other words, where is cosine negative? Cosine is negative in quadrants 2 and 3. So the question is, in which quadrant is tan both positive and cosine negative? Does both of these things occur? It's in quadrant 3. The correct answer to this question is C. Now let's have a look at finding the measure of angles given their trigonometric ratio. Very important topic. Determine the measure of all angles that satisfy the following. Use diagrams in your explanation. Sine theta is equal to a negative root 3 over 2, where theta is between 0 and 2 pi. What we're looking for here is all the values of theta where the sine of the angle is equal to negative 3 over 2 within this domain of 0 to 2 pi. So it does say this use diagram, so it's critical that we create a diagram here. And of course, we're going to use our cast rule again. Always draw a diagram for these situations, and always use your cast rule to help you determine the measure of the angles. Sine is negative root 3 over 2. Sine is negative in which quadrants? Well, hopefully you'll agree that sine is negative in quadrants 3 and 4. So I'm going to draw terminal arms in quadrants 3 and 4. I'm just going to draw it anywhere. Doesn't really matter at this point where I draw them. We'll figure out what the reference angle is shortly. So what we're saying here is that we have theta located in two quadrants, 3 and 4. We know that the sine of the angle is negative root 3 over 2. So if the sine of the angle is negative root 3 over 2, remember that the point associated with a certain reference angle does have sine at negative root 3 over 2. Sine of negative root 3 over 2 occurs as my second coordinate. The first coordinate is a half. So in this quadrant, if we have a point with sine being negative root 3 over 2, cosine being a half, the same is true over in this quadrant. I have a point on the terminal arm where sine is also negative root 3 over 2, but in this case, cosine is negative 1/2. But in both quadrants, you see that sine is both negative root 3 over 2. So there's two answers to this question. There's theta 1, and here's theta 2. We just need to determine the value of those two angles. The point associated, the reference angle associated with that point of 1/2 negative root 3 over 2, we should recognize that as an angle of 60 degrees, which we can write as pi over 3. We should memorize that and know that 60 degrees is pi over 3. So my reference angle is 60 degrees or pi over 3. The same is true on the other side. The reference angle over here is again pi over 3. If the reference angle is pi over 3, and I'm looking for the measure of this angle, because remember theta is always measured from the positive x-axis, the measure of this angle is going to be 3 pi over 3, which is pi, plus 1 pi over 3, which is 4 pi over 3. So theta 1 is 4 pi over 3. Again, you want to think about 180 degrees as pi, and of course 360, which is 2 pi. But in terms of pi over 3, pi is 3 pi over 3, and 2 pi is 6 pi over 3. So as I said, the first angle, if we rotate as far as here, that's 3 pi over 3 plus 1 pi over 3 is 4 pi over 3. The second value of theta, which is this one right here, if we were to rotate all the way around, we would be at 6 pi over 3. That would be one complete rotation. But we're not all the way around here. We're 1 pi over 3 less than 6 pi over 3. 1 pi over 3 less than 6 pi over 3 is going to be 5 pi over 3. There are my two values of theta, where sine theta is equal to negative root 3 over 2. And there are two answers between 0 and 2 pi. Let's have a look at B. The cotan of theta equals positive root 3. So again, I'm going to draw a diagram here to help us out. Cotan is positive in two quadrants. If we use our CAS rule again, cotan is positive in the same two places that tan is positive. Tan is positive in quadrants 1 and 3, here and here. So cotan is positive in 1 and 3. So I'm going to construct two terminal arms in both quadrants. Or a terminal arm in each quadrant, I should say, I guess. Terminal arm here and a terminal arm here. Cotan theta equals a positive root 3. Again, we're going to use our special angles in order to figure out to measure the reference angle here. Cotan theta equals a positive root 3. So let's think about the possibilities. We got 1/2 root 3 over 2 could be a possibility. Another possibility could be root 3 over 2 and 1/2. So we're not quite sure at this point what the coordinates of that point is. It could be one of these two possibilities, because we know it has a root 3 in it, so it's one of these two possibilities. We do know that cotan of an angle is equal to cosine over sine. If I were to take those 2 points and do the cosine of the angle divided by the sine of the angle, one of them should give me root 3. Cosine divided by sine. Let's try this one first. Cosine of the angle is 1/2. Sine of the angle is root 3 over 2. The first quadrant is cosine, the second quadrant is sine. So I get 1/2 and root 3 over 2. When I divide that out, I get 1 over root 3. So that was using that point. Let's try this point here. The cotan of theta, using this point, is going to be cosine theta over sine theta. Root 3 over 2 divided by 1/2. If I do root 3 over 2 divided by 1/2, it will give me root 3. Quick little note here. If you had the same denominator in two fractions, they simply cancel. That's how I very quickly got my answer of 1 over root 3. Same denominator in two fractions divided. The two denominators actually cancel. The reality is we multiply by the reciprocal, but in the end they will cancel. So my answer is root 3. So you can see that the cotan of theta is equal to root 3 if the point on the terminal arm is root 3 over 2.5. So if the point on the terminal arm is root 3 over 2.5, we should now know that the reference angle associated with that point is 30 degrees or pi over 6. Now, let's look at our domain. We're only interested in the domain between 0 and pi. The domain between 0 and pi is right in here. Although there are two answers between 0 and 2 pi, that's why I drew two terminal arms. Within this restricted domain between 0 and pi, however, there's only one answer, and that's right there. So I'm not really concerned about this answer here, because my restricted domain tells me I only need to be concerned within this domain. So the measure of the angle theta is actually equal to the reference angle. So theta is equal to pi over 6. And there's only one answer we're looking for in this case, as I said. Okay, hopefully we can squeeze in on the same diagram here. Secant theta equals, on the same page, secant theta equals -2 between negative pi and 0. See if I can separate this here a little bit. So we don't get confused. There we go. Okay. Secant theta equals -2. Again, we're using our casserole. Where is secant negative? Secant is negative in the same place that cosine is negative, because secant is the reciprocal of cosine. We know that cosine is positive in these two quadrants, so secant and cosine are both negative in these two quadrants. So I'm going to simply forget about my restricted domain at this point. I'm just going to draw two terminal arms in these quadrants. So between 0 and 2 pi, secant is negative in these two quadrants. Let's look at our restricted domain so we can quickly narrow down which answer we're looking for here. We're looking for the answer between negative pi and 0. Between negative pi and 0, there's negative pi, there's 0. So between negative pi and 0, there's again only one answer that I'm looking for. I'm not looking for both answers. Oftentimes we do look for both answers because our domain is between 0 and 2 pi, but in this case we want just one answer, and that's this answer right here. So let's eliminate this terminal arms. We don't need it anymore, really. So we're looking for the value of this angle theta, or if we go in the positive direction, this angle theta. But of course, we want the angle between 0 and negative pi, so in reality, we're looking for the negative angle. So this is really theta we want here, not the positive angle of theta. We want the negative angle of theta. Okay. Secant is equal to -2. Secant is the reciprocal of cosine. Secant theta is equal to 1 over cosine theta. is equal to negative 2. If I take the reciprocal of both sides, I will get cosine theta equals, take the reciprocal of negative 2 over 1, I'll get negative 1 over 2. So cosine theta is equal to negative 1 over 2. Cosine is the first coordinate of your point, so I'm looking for a point that has a coordinate of negative 1 over 2, and of course the other coordinate will be negative root 3 over 2. Again, critical that you know how to find the reference angle for those points. And the reference angle here, you should agree, is going to be, we got a 60-degree angle, or pi over 3 is my reference angle. So if my reference angle is pi over 3, then what's theta? In the negative direction, because again, we want an answer which is negative, if we rotate all the way to here, that's pi, or 3 pi over 3, but I'm 1 less than that. I'm 1 pi over 3 less than 3 pi over 3, so theta is equal to 2 pi over 3. There's our value of theta. We're seeking theta is equal to negative 2. Example 3. Solve for theta. Cosine theta equals a negative root 3 over 2, where theta is between negative pi and pi. Again, notice your restricted domain here. Might be a good idea for you to pause the recording and try this one on your own before I actually do it. Okay, I'll proceed to do this now. Cosine is negative root 3 over 2. Using our CAS rule again, we need to determine where cosine is negative. Cosine is negative in quadrants 2 and 3. So we're going to draw terminal arms in quadrants 2 and 3. Doesn't matter where I draw them, as long as I place them in these two quadrants. Cosine is negative root 3 over 2. So cosine being the first coordinate of my point is going to be negative root 3 over 2, and of course the other point, or the other coordinate of that point, is 1/2. Down right here, the same is true, negative root 3 over 2, and negative 1/2 in this case. Again, let's recognize the reference angle associated with that point, root 3 over 2.5, the reference angle associated with that is 30 degrees, or pi over 6. So my reference angle is pi over 6 in both cases. Now let's consider our restricted domain. We want the answers between negative pi and positive pi. That's really two domains here. If we want to think about it as two separate domains, we can think of it this way. Between negative pi and pi, because all angles are measured from 0, let's think of this as theta being between 0 and pi, and theta occurring between negative pi and 0. This will include the entire domain. But again, because theta is always measured from the positive x-axis, which is 0, I'm going to break this domain into two regions. Between 0 and pi, there's one answer between 0 and pi. And between negative pi and 0, or between 0 and negative pi, there's the other answer. So these are the two values of theta that I want. Let's call this theta 1 and let's call this theta 2. So theta 1, between 0 and pi, again this is pi over 6 as my reference angle, so we want to think in terms of pi over 6. So this is 6 pi over 6. I'm 1 pi over 6 less than 6 pi over 6, which of course is 5 pi over 6. The second value of theta is this one right here. And it's a negative angle of rotation. And it occurs at negative 5 pi over 6 for the exact same reason. This is negative 6 pi over 6 if I want to rotate all the way to here. I'm 1 pi over 6 less than negative 6 pi over 6, so it's a negative 5 pi over 6. So 5 pi over 6 and negative 5 pi over 6, there are my two answers right there for theta. Example 4. For what value of theta is tan theta equal to root 3 and sine theta equal to negative root 3 over 2? I would think about, first of all, where is tan positive and where is sine negative? This will narrow it down for us. Where is tan positive and where is sine negative? So let's think about that, using again our cast rule. Sine is positive in quadrants 1 and 2, but tan is only positive in quadrant 1. So if tan is going to be positive and sine is going to be negative, that has to occur, tan is positive in these two quadrants, sine is negative in these two quadrants. Sorry, let me correct that. Let's make this sure we get this correct here. Tan is positive root 3 over 2 in these two quadrants. In quadrants 1, and I'll just circle them, in quadrants 1 and 3 where tan is positive. And where is sine negative? Sine is negative, and I'll circle those as well, in these two quadrants. So if sine is negative in these two quadrants, and tan is positive in quadrants 1 and 3, the only place where my terminal arm could exist is in quadrant 3. So I now know that I'm looking for an angle in quadrant 3. So my terminal arm has to be located right here in quadrant 3. So let me draw it in quadrant 3. Here we go. And sine is negative root 3 over 2. Sine is the second coordinate. Therefore, the first coordinate is 1/2. Again, if we think about the point associated with that, or the reference angle associated with that point, 1/2 root 3 over 2 is 60 degrees, or pi over 3. There's my reference angle. If I know that to be my reference angle, then theta is going to be 3 pi over 3 plus 1 pi over 3, which is equal to 4 pi over 3. There's the answer I'm looking for. And by the way, the tan of that angle is also going to be 4 pi over 3. Is also going to be equal to root 3. I can check it, but I know that's what the answer is going to be, okay? Because the sine of the angle in that quadrant is 4 pi over 3, or the angle is 4 pi over 3. I can check the tan of the angle, just to be sure I have this right. I'm looking for the tan of the angle. Tan of the angle is the sine of the angle over the cosine of the angle. So sine over cosine is a negative root 3 over 2 divided by 1/2. Again, recall what I just mentioned to you, that if you're dividing two fractions and you have the same denominator in both, you can just ignore that and you end up with, oops, sorry, I left out a sign here, didn't I? Sine, sorry. In this quadrant, cosine is negative, of course, so it should be negative 1/2 and negative 1/2. And now I get the answer that I'm looking for, which is a positive root 3, just as I expected. So the correct answer is clearly C. One more example. Now this example deals with general solutions. It's simply saying solve for cosine x equals root 3 over 2. So we're looking for the general solution for where cosine x equals root 3 over 2. The general solution means all possible solutions. That's what it means. All possible answers for cosine x equals root 3 over 2. There's no restricted domain here. So again, let's consider where cosine is positive. Cosine is positive in these two quadrants here. And I'll draw terminal arms for you. Here and here. And we're looking for, again, to measure the reference angle, which is what's critical. Cosine goes root 3 over 2 and 1/2. And of course, over here, cosine is root 3 over 2. Sine is negative 1/2. The reference angle you should recognize is 30 degrees, or pi over 6. As both reference angles are pi over 6. So let's think about the two values of theta that exist between 0 and 2 pi. The two values of theta that exist between 0 and 2 pi are theta 1, which is pi over 6, and theta 2, hopefully you'll agree that this is 12 pi over 6 because it's 2 pi. I'm 1 pi over 6 less than that, so that's 11 pi over 6. So there are my two values of theta between 0 and 2 pi. But we know that there are lots of angles that are coterminal with those two terminal arms. And the way we represent the coterminal angles, of course, is we say plus 2 pi k, or 2 pi in this case we use k, 2 pi k, where k is an element of I, and plus 2 pi k, where k is an element of I. This will represent all the angles that are coterminal with pi over 6, and all the angles that are coterminal with 11 pi over 6, because they are all solutions. All of them are solutions to cosine x equals root 3 over 2. So we're looking for this as our answer, pi over 6 and 11 pi over 6, plus 2 pi k. The correct answer is A. I think that's the last example, and it is. Key ideas, quickly, simply says this. We can determine the trig ratios for an angle in standard position from the coordinates of a point on the terminal arm of theta and right triangle definitions of trigonometric ratios. That's what we did there, right? We determined the trigonometric ratios by using the coordinates of the point on the terminal arm.